Hi, my name is Natividad Perez, and I will be going over linear approximation. Let's start off with the definition. The definition of linear approximation is an approximation of a general function using a linear function, sometimes called linearization. For instance, if we're trying to find a point, let's call it A, we have to use the tangent line in order to find f of A. Another example could be B. If we're trying to find a point B right here, we have to use this tangent line in order to find f of B, because the tangent line is very close to the function at any point close to A. Now you may be asking, how do we use this topic in mathematics? We use linear approximation in circumstances where the function we are dealing with is especially complicated, and when finding the y value of a given x value proves to be a difficult process. It can make the equation more easier to follow without using a calculator. Although the problem won't be exactly the same as the first, it can be good enough. It can also be really helpful when we're trying to estimate square roots, but essentially numbers that aren't perfectly squared, like 3 or 9.2. We use linear approximation using this formula, which is L of x equals f of a plus f derivative of a times x minus a. Now you might be asking, who discovered the topic linear approximation? Linear approximation is largely attributed to Isaac Newton, as he developed the fundamental ideas behind calculus, including the derivative, which is a key component in this topic. Now that I have learned and taught linear approximation, I believe that it is a very difficult topic to learn because it involves many topics within that topic, making it a long and confusing process. Sometimes I had to go and do outside research just to understand how linear approximation was applied in different scenarios. I feel that although I face some difficulties understanding it, I feel like it is very relevant because in some cases where we don't have access to a calculator, it could serve as a good tool